Well, thank you for doing that.
Yeah, it's live now, so.
Oh, it's
whether you
going,
see
all
it
right.
Can, we'll be using it.
Yeah.
Oh, so it's actually recording.
Yeah.
That one
Take
is,
care.
yeah, I'm gonna start that one later.
Okay.
How you doing, Scott?
Living the dream. How about you?
Yeah, I'm all right.
You can put a real production together now, 2 cameras.
Right?
editing. Which
Yeah, I
side's
wanted
my
to-
best side, my front or
That's-
the
that's right.
side, or-
No, I wanted to experiment with, so Pastors goes right to YouTube. It's just live streaming directly to YouTube.
Oh, it's live, really?
Yeah. And so it's just going to YouTube as we're, thank you, as we're talking. I wanted to record it on, but his is in, I think, standard def. I wanted to record it in high def and just, I don't know, experiment with it,
Yeah.
see.
Put it on a DVD, put it on Amazon, see what you can
That,
get.
that's
for it.
right. No, just I mean, actually, I do want to do that in the future, but this is just to practice and see what it does, and I probably won't do anything like that other than see how it works.
Do you have an extra chip in there or just the phone memory? Like if you
If
buy
I
that-
remember correctly, the phone memory is 128 gig, so it should be. I think like an hour's about 4 gig, I think, at
Oh,
HD.
is that it?
I think.
Okay.
That's kind of why I'm doing it. I'm trying to
See
see
all that.
how it all works out, yeah. Crazy weekend. Good morning.
Good morning.
How are you?
I'm fine, thanks. How are you?
Doing well, thank you.
Good.
Share. Hard enough. That's me. Morning, Mark. How are you doing?
Oh, fine as always. How about you?
I'm all right.
Wow, you got 2 angles this morning.
So this, I'm just experimenting. So that one goes, that's Pastors, which is what we've been using, which goes straight to YouTube. And I'm just experimenting, doing high def and, I don't know, seeing what it does, how it works.
Make yourself taller.
That's right.
thinner, whatever you.
Better looking.
Some
Younger.
wild filters in there. So now you're not live streaming yours though.
No.
So you're hoping you've got enough space.
Yeah, that's actually kind of why I'm doing it. It's just a test to see if I've got enough space, see how it looks. It's just just a trial, see how it goes.
Morning, instructor.
Good
How you
morning.
doing? How are you today?
No apple?
Oh, yeah, that, I got the policy.
Right?
If you're gonna brown nose, you gotta do it right.
That's right. Come
I
on.
wanna sit closer, but the seat's taken.
class has been getting bigger and bigger and bigger every week, but I don't know, we might have a low.
Oh, there's some vacations.
Oh, it
President's
is
Week.
Birmingham school drop, so yeah. Yeah,
Thank you.
you're welcome.
Say, something's gotta be going on.
The OEMs are off tomorrow, President's Day.
Yeah. Yeah, long weekend for some schools, entire week for others, so.
We're not off, surprisingly.
We're off Monday, right? I'm pretty sure we're off Monday.
No, it's not on my calendar.
Must not be, must not happen.
Yeah.
I thought for sure we were off tomorrow.
No, it's weird, they give us, you know, the 18th isn't.
Because wasn't it supposed to be a 4-day weekend and then they had to reduce it to 3 because
The
of.
school.
I'm talking the school.
No, yeah.
Oh, you're talking
I'm
about
talking
school.
work.
Yeah.
Oh,
Whatever,
okay.
yeah.
No, I'm talking school. No,
Yeah.
work, yeah, I'm not off tomorrow either.
Yeah.
No, hi Scott,
Hey,
how you doing?
I think I'm all right. Now I'm all worried about what I have to do tomorrow. I know I'm slightly connected to you too, but you were talking about school.
Yeah.
Well, we were
Not
confused talking about both.
Yeah.
Right.
One of them, the
Now
one-
we're on the same page.
Oh, okay.
Hey, before we get started, I am reading a phenomenal book.
I did watch this
It's,
last week, yeah. That's
at
right.
least right now in the thick of it, I'd say it's probably in my top 10 of all.
Is that your
time.
phone?
This is my phone.
Oh, mine's over there, that's pretty
Yours
funny.
is tape, yours is recorded.
Mine's recording. Okay.
It's called, The Year They Tried to Kill Me.
Okay.
And it's written by a doctor about his first year of internship out of med school. And he wrote it himself, so it's like in, like, by day, by week form.
Good.
And it is so awesome. You should read it if
Yeah.
you get a chance, because it's got, it's a combination of medical stuff, but really dumbed down. And then there's a lot of poignant stuff. He talks about his twin brother who passed away, and then there's just this gut-busting humor at times. Because he,
What's its main?
Yeah, it's good.
what my first year in
It's
this
all
was
about
like,
first year.
and moving from hospital to hospital, different services, different people he dealt with, the administration, and the patients.
You go to gymnastics.
But there's a humorous side to some of the things he deals with, and then a poignant side to where the questions what the doctor wants to be.
But yeah, it's good.
Bill, I don't think we'll need it. No.
But now-
Thank you.
Oh, you did?
That's cool.
I would highly recommend.
Oh, but
That's his point, I didn't even notice.
Yeah, see, that was one of my hangovers, I was pretty out of shape, but playing full court, people that are pretty good, it's like, oh man.
Oh, yeah.
Have you been back since the time I saw you?
I went the one time.
I don't go very often myself. Have you been getting there lately?
I've been going very consistently
Oh, good.
for about 4 months.
I need to get back.
Yeah.
It's hard.
I know, it used to have a lot, I had a small group on Thursdays.
Oh, that was
Yeah,
your
so, but every
your
year
issue.
that-
Good morning.
Yeah, I haven't been riding my bike so I should try it again.
Yeah, that helps. So you riding?
Inside.
Oh, yeah, right.
We're wide.
Okay. That's short for riding.
Yeah, oh, need your pencil?
Ah, yeah, they probably so, yeah. I wasn't sure if it was a new line, something.
Did you get a hand now? Yeah. All right.
Oh, really? Is that Royal Oak? Oh, that, I've been in.
What time you got? Everything on your phone now.
9:04.
All right, let's get started.
Just like.
All right, why don't we go ahead and get started? We might have a smaller crowd today with the schools being off this week. I think people are gone. So let's get started. We're going to watch another video, but before we do that, Mark always asks me really challenging questions at the end of class when he and I are standing around afterwards. And so he makes me go off and do some homework and look things up. And so I got a couple things I just want to share with you before we get started. The first thing Mark asked me he said to me at the end of class, he goes, Jeff, I think you're more of an evolutionist than I am. And I'm like, whoa, what are you talking about, Mark? And he's like, how do you explain the diversity of life coming about in 6,000 years? At least the evolutionary viewpoint is, this diversity of life takes millions of years to come about, but you believe it comes about in 6,000 years. I'm like, wow, that's a great question. I hadn't actually thought of that before. And like all of the questions that come up, somebody has asked them and somebody has answered them already. So I went out and I looked this up, and this is what I found that's out there. One of the things about this topic is there are a lot of organizations out there who do evolution and have evolutionary information out there for you. There's only a handful and a couple big ones that have creationist information out there, especially a young Earth creationist, which is what I would consider myself to be. Mark would consider himself to be an older creationist. Is that a fair assessment?
Yeah.
Okay, I don't want to label you.
Is that a label?
I don't know.
I can't say I've heard that one, so I'm thinking like, yeah, okay, all right.
I mean, you believe in creation,
I'd
but
be
you
okay with
believe in an older Earth,
Yeah,
not a 6,000 year Earth.
right, and I don't necessarily believe in creation of all the orders being present at the same time,
Okay,
like with,
but you believe God
yes,
started the process and
right.
directed it potentially in some way, right? Okay. So there's only a couple big organizations out there that have young Earth creationist information. So you have less to pull from when you're looking for counter arguments to some of this stuff. But what I did find on this particular topic, and from a genetic diversity standpoint, and how do you have all diversity of animals you see today? From a genetic standpoint, the creationist answer is, well, God put all of the needed genetic material into the animals at the very beginning of creation, right? So whatever you see today, that genetic information was there from the start. And one of the things, and we're going to talk more about genetics and DNA in subsequent classes, but one of the things that they found with genetics is, 10 plus years ago, there was a section of the genetic code that they referred to as junk DNA. And it was thought by everybody that it didn't really have any impact on what takes place within our bodies and the genetics within us. But what they have found over the past 10 or so years is that genetic information is much more complex than they initially thought, which to me doesn't come as any surprise. But that junk DNA, what was so-called junk DNA, actually they're finding isn't junk, and it does have a purpose, although they're still trying to define it all. So the level of information in the genetic code is vast. And you can only imagine that at the beginning of creation, what God could have put into animals at that time is everything they would have needed to then, as they move from environment to environment to environment. And remember, we believe natural selection happens, right? So as an animal moves to a cold environment, those with short hair may die off, those with long hair survive, and they're propagating the long hair from that animal. That's just a basic example. So natural selection does happen. Animals can change within their kind as they move around. They just don't change from one kind to another kind. So the genetic diversity is there from the beginning. So the other part of this question is, well, how do you get population growth over 6,000 years? And actually, it's worse than 6,000 years as I went out and looked at this. It's more like 4,600 years because you got to start all over at Noah's flood. All right, Noah's flood, everything's wiped out, and you're starting all over at Noah's flood. And again, this one example I found, they took the African and Asian elephants, which have some of the lowest breeding rates of animals. A lot of animals produce offspring much quicker. These elephants, about every 2 years. And what they found using known population models, I think they know elephants have babies this often, and they can put models together. And after 50 years, you'd only have about 35 elephants. 100 years, you'd have about 750. And then as time goes on, the numbers explode, just with the population models. The numbers can explode. Now, those numbers assume there's no predation, there's no food supply issues, there's no external factors wiping out these elephants or killing off certain numbers of elephants. But just the numbers alone can show you that over a 300-year time frame, you can have lots of elephants repopulating the earth, and with the genetic diversity that's built into the animal, then it's conceivable, it's realistic, right, that you will see the type of diversity you see today all over the earth with the animal kinds. So that was the first question that he had asked me. The second thing he had asked wasn't really a question, more of a statement, was it would be really neat to see I think you had said a debate, right, between these different views that we've been talking about. An old Earth, billions of years versus a young Earth, 1,000, 6,000-ish years. And it turns out there is a really good debate out there that I was able to find. It's between what they would call a young Earth creationist, his name's Jason Lyle, and an old Earth creationist, his name's Hugh Ross. Hugh Ross is, from what I can tell, and I've known of him for years, but what I can tell is he's probably the leading advocate for an old Earth creation, and he's got a website out there with lots of information on it. Both Jason and Hugh, PhDs, super smart people. As you watch this video, I imagine a lot of the science just is going to go over your head. A lot of it went over my head. They're astrophysicists or something, but it was extremely interesting, though. Even if you take, both of them were able to defend their view scientifically, what they would say looking at the data, right? But they both have different endpoints. What's interesting is their starting points. Both of them would say they take a literal interpretation of the Bible. Both of them Christians, believers. Jason Lyle believes in the literal 24-hour day. Hugh Ross believes that the days are long periods of time. And Hugh will take you through all kinds of what he views as biblical support for his point of view. From my reading of Scripture, from my understanding of everything, I go back to three main things that lead me to believe that Hugh's interpretation is not the correct one. One, I think it's very difficult to say that the day in Genesis is not a 24-hour day. I think a literal reading of that tells you that it's a 24-hour day. Exodus, then, in the fourth commandment, in 6 days the Lord created the earth, and on the seventh you shall rest. That's validation outside of the Genesis account, that it was a 6th literal day. And then the problem of sin. If you don't have sin until after Adam and Eve, if you don't have death until after Adam and Eve sinned, then where do you have the fossil record? You can't have anything until after Adam and Eve sinned. I think those three things are, from a biblical standpoint, lead me to believe in a young Earth. But the debate is very interesting. They both, Hugh Ross will say, I take a literal interpretation of the Bible, but it's different than Jason Lyle's. And they argue their points, and I put the link on there. I would highly recommend you go and watch it. It's really interesting. I have another link on there just for an article that is, I think it's about the best scientific evidence for a young Earth. I just put that on there if someone's interested in going and reading that as well.
On where?
It's on the sheet of paper at the top.
Thanks.
It's just listed there. You can type that in and go see it. But the debate is really interesting. All right. Yes, sir.
If I could, yes, one of the reasons I thought it would be interesting to have kind of both viewpoints is the video from last week. I thought, and I can't remember that guy's name. That wasn't Jason Lyle, was it?
No, I think it was Terry Mortensen, I believe. And he's who we'll see again today.
But I thought he did a very good job of presenting a picture that made you think, oh my gosh, anyone who thinks the Earth is old is just out of their depth. They're just crazy.
Right.
But then you're like, oh, well, he totally cherry-picked a bunch of data to support his view and didn't mention some of the things that wouldn't support the view. So, I mean, for instance, while there's definitely evidence of some floods happening in geology, there's other things that you wouldn't explain with a quick couple-day deposition after a big flood. For instance, I was out west with my family a couple years ago in Utah, and you get these dinosaur footprints that have been preserved. So it's not just bodies of animals that were preserved in the fossil record. I don't think anyone would argue you would get footprints deposited at different layers after a flood. That would be wild.
No, I would argue that you're more likely to get them after a flood because as the flood waters are rising and then the material is soft and dinosaurs are walking in them, in order for that to get fossilized, you would have to have another layer rapidly bury that layer. Whereas if it's a millions of years thing and if a dinosaur walks on it, over a number of years, wind's just going to blow it out. and you're not gonna have a
But then you're
footprint
basically seeing an animal have to walk across the layer while a torrential flood is depositing material on top
anymore.
of
The
that
next layer on top of it, and if you think of a global flood and the water's rising and things trying to get away from the water as it's rising, I think that's very
I mean,
realistic and
I've
plausible.
waded in streams that will pull your feet out from underneath you, and if you're talking about one of these giant flood events, ain't no Allosaurus walking across that to deposit footprints.
Well, I think waters are
while it's
rising,
flooding.
right? And I don't know exactly how it happened. Yeah, I don't know how it happened, but I think it's,
And so another, and I
Go
didn't
ahead.
read anything online, this is just a couple
Yep,
ideas that
yep.
popped into my head. But also, so I work in pest management, and diatomaceous earth, it's used in all kinds of things. It's used as an insecticide,
I
it's
know
used
that
in
stuff.
pool filters, car wax, it's in a bunch of products. But diatomaceous earth, you get these giant stretches of deposited diatoms. And if you took every diatom alive on Earth right now and killed it and let it deposit, you wouldn't get these huge, some of these layers are massive. And at a minimum, you would assume this is thousands of years of diatoms living, dying, depositing. You couldn't get this in a short time period. And so there's just a couple of things
Yeah.
like that where I think if the other side was present, they would call them on that stuff.
I absolutely agree, and I think I agree with your point that they would call them on it.
Yeah.
And I think if you watch the debate, you'll see that these two scientists just go back and forth with each other with the science, right? They're just, oh, hey, this is what my measurements and my data says, and but this is what my measurements and my data says. And I think that's really a lesson here in that I don't think we know, right? So where do we go back to, where do we start from? Do we start from man knows, or do we start from the Bible knows? And again, the Bible's not a scientific textbook, right? But the Bible tells us some very clear things. 24 hour, 6 days. It tells us when death comes into the world, and when we start putting that into a framework, and that's our starting point, then where does that take us? If we start with man's framework of billions of years, well, I don't think science is certainly not settled. And even when we call it science, a lot of the we haven't talked about this, and actually one thing I should have done earlier is actually define what science is, right? The scientific method. How do we know something is true scientifically? A lot of the things that we call science hasn't been through a repeatable process, and we're going to go through this next time, but you have to be able to have a hypothesis, test it, show that it's true, and repeat it over and over and over again for something to say, this is scientifically proven. A lot of these age-old, how old's everything, you can't do that with, yeah.
You have a presentation you want to do?
No, it's okay. This is
One last thing that is that as Christians, getting bogged down in how the earth was created too deeply, we don't do that with the rest of the Bible. In other words, the burning bush. How'd that happen? Well, God's all powerful. We just accept that. If we're Christians, now non-Christians wouldn't believe that, but as a Christian, we look at it and say, okay, well, one way or another, God made it happen, and He'll explain it to us someday. Lot's wife turning into a pillar of salt. How'd that happen? Well, but when we get into the creation, we dig down and try to find an answer for every possible question. And at some point, as a Christian, we have to accept that there are things that an all-powerful God does that we as humans will never understand until He explains them to us. So I do find it interesting that there's so much debate about how all the science can be explained in this one area of.
And some of that comes out in the debate, which I'd highly recommend you watch it. It's very interesting.
Yeah.
Yes, sir.
If I just, so I'm glad you brought up the point about kind of defining science. And so I guess the point that I was roundabout trying to get to is, good science is kind of demonstrated by someone who takes a hypothesis and then tries to poke holes in it, tries to find things that don't line up with it. And poor science is taking a hypothesis and then just looking at the data that supports it. So that's certainly one way to measure the validity of some arguments.
And I think, so when you look at the video isolated, I can understand you say, oh, it's totally one-sided. I look at it as saying it's poking holes in the uniformitarian assumption, which is a big part of what we've been talking about and how evolutionary timeframes come about as this uniformitarian idea. Well, if you can show that some of these geological record, fossil record can actually happen in a short period of time. Doesn't mean in every instance it happened in a short period of time, but that it can happen in a short period of time. It starts poking holes in this uniformitarian theory that evolutionists hold to. And if that's true, right, that something can happen in a short period of time, then why couldn't the flood be what has caused our geological record and the whole fossil record? Because we can show it. We have science, and actually the video today is going to get into this even more. Observable, measurable science shows that this happens. Where we can't show that millions of years produces a fossil, because no one's been around for millions of years. But we can show that short periods of time can create fossils and can carve massive, the Grand Canyon could easily have been caused by the flood. It doesn't need millions of years. Again, it's more in the video today. So I agree. The point of what I'm showing is, because we're coming to this study with this view of evolution's true, and it has to be true because all the smart people say it's true, but we're showing counterexamples of where it's not true, of where what the Bible says is a plausible explanation for what we see in the world today. And there's actual science, measurable science that we can see today that supports what the Bible says happened. Not that we can prove everything one way or the other. I don't think we'll ever be able to do that. All right. Any more questions on that?
That's,
Scott, did you have something you were going to say?
I was just gonna add to Scott's comment about why we focus on how the earth was created. It's just, I think, because we can, right? And God made us with minds that are, seeking to learn and create and all that. And God's footprint is on everything. So it's a fascinating thing to look at. So it's easy to go off track, right, and reach the wrong conclusion. But God's footprint of like DNA and the laws of nature and physics and things that you can discover and calculate, it just seems to lead to just an adventure that, Lot's wife turning into a pillar of salt probably blew away in 3 minutes or whatever, whereas this is here. The mark is everywhere, and you can do your best to understand it, but that's one reason why I think it becomes the focus of a lot of debate.
Yeah, it shouldn't be threatening to ask these questions, right?
Right.
We're here to learn, and it shouldn't be threatening to anybody to ask and learn and try to understand. So it's not that we're challenging. Well, I think we are challenging, but we're trying to understand and learn. That's good. That's helpful.
God's probably smiling down on us going, let them debate, let them learn. He goes, and when they can't figure it out, maybe they'll realize it's me that did it.
Yeah, and I think, the first sin was Adam and Eve's hubris, right? They thought they could be like God.
Yeah.
And they thought I think today we still think we know everything, or we can know everything. And I think that's part of the lesson in this, is that we can't know everything. We won't know everything. Every time we think we've found the smallest particle, you go from down to the cell, then we find there's things inside the cell. Now we're finding there's things even smaller than that. And then every time we think we've found the extent of the galaxy, things get bigger, and things always get bigger and always get smaller as we figure things out. And I have this weird theory that that's always going to be the case, because if we can ever figure out how big or how small something is, well, then we're close to being like God at that point. And we can't be. So we're never going to figure it all out. Now, that's not very scientific. That's more philosophical, but
You guys, you're bumming me out. Come on, education is a huge success story. The average person graduating high school today knows more than the most knowledgeable person did from 200 years ago.
for sure.
Actually, all the knowledgeable people on the planet, put them together in a room, and the average high schooler would be like, oh, you guys don't know about cells? That's fun.
It might be turning around though.
It's, so, when I hear you talk like that, That's strange. I think human reason is, it's a powerful tool. It's one of the most powerful tools
Yeah.
on the planet.
Well, I think God gave us that human reason, and we're meant to use it and meant to figure things out. That's why we have computers. That's why our medicine is so good these days.
Right.
Right? Fully agree with you.
So just to wad it up and
Science is-
say, it's crap,
Oh,
we're never
no,
gonna
well,
know.
I think you misunderstood what I said. I'm
That's
certainly
what
not-
it sounded like to me.
All right, well, that's not at all what I'm saying. I mean, I'm an engineer by background. I love science. I mean, I wouldn't be looking and spending all the time I do researching this stuff if I didn't like science. Science is great, it works. Absolutely. I just think we are not meant to know everything God knows, and we won't ever. Or we would be like God, and we can't be.
Yeah, I agree.
That's
We'll
it. That's
never
it.
know everything. There's always more. Every time we turn something
That-
over,
that's-
there's
that's my
always
only
10
point
more
there, Mark.
questions.
Yep.
But that's not to say that everything we've learned is,
Oh, absolutely
Suspect.
not. We,
Right.
because we can test it, we can prove it. We know things work.
right, okay.
Yeah, absolutely. Thank you for clarifying, though. I didn't want to leave a wrong impression. All right.
Okay, in our last session, we talked about the importance of presuppositions and
Is that loud enough?
assumptions that affect what we see and how we interpret what we see in the geological record. And that, as Dr. Ager talked about, geologists have been brainwashed from seeing any evidence of catastrophe in the flood, in the rock record. And now, at the end there, we talked about some of the evidences that the geological record was deposited basically in one very short period of time. Rapid, successive deposition in a violent event. And of course, that reminds us of the biblical flood. And I want to just highlight, just very briefly, some of the biblical evidence from the book of Genesis that this flood was a global flood. Some Christians today believe it was a local flood in the Mesopotamian Valley, modern-day Iraq. But the biblical text doesn't support that. First of all, the purpose of the flood. The purpose of the flood was to destroy not only sinful man, but Genesis chapter 6 tells us it was to destroy sinful man and all the land animals and all the birds and the surface of the earth itself. And only a global flood would accomplish that, because animals living in North America, South America, Europe, Russia, India, China wouldn't be bothered by a flood in the Middle East. Only a global flood fulfills the purpose of the flood. Secondly, we have the character of the flood. The Bible describes the flood as being a violent catastrophe. In one verse, in Genesis 7:11, it tells us that the water came from the fountains of the great deep bursting open and the floodgates of the sky opening. So water came from above and water came from below. And this rain was not a spring rain to water the garden. This was a monsoon, 24 hours a day, day after day after day, all over the world simultaneously. And the fountains of the deep, as we look at those words in the Hebrew text, it's very clear that this is talking about tectonic activity, earthquakes and volcanoes going off all over the earth, and subterranean waters coming in to the surface of the earth. So it was a violent, violent catastrophe with all kinds of hurricanes and earthquakes, tidal waves, tsunamis. This was no picnic. And then we see the depth of the flood. The Bible says very clearly in Genesis 7 that the water covered all the high mountains and sent everywhere under heaven. And so since water seeks a level plain, the only way you're going to cover any mountain anywhere is if the water covers the whole planet. And then finally, the duration of the flood. The Bible tells us a very specific chronology that from the day that Noah went into the ark until the day he came off and all the waters had subsided was 371 days. No local flood can last over a year, but a global flood would. So, what would we expect from a flood like that? Well, we would expect billions of dead things, plants, animals, to be buried in rock layers that were once wet sediments of sand, silt, clay. And we would expect to see those laid down all over the earth. And the miracle of miracles is that that's precisely what we find. Billions of dead things buried in rock layers that were once wet sediments, and we find them all over the earth. We find marine fossils in the tops of all of our highest mountains, the Himalayas, the Alps, the Rockies. So it fits what the Bible says. Now, we can learn a little bit about the flood and the creation account and how that affects the how that relates to the rock record. You have creation week, which was just 6 days. That was a very short period of time. And then 1,600 years leading up to the flood. And then the flood was a year, relatively short period of time. And then the post-flood era. But the rock record associated with those periods of time are very different. So in creation week, we would have had a lot of rock formed there at the beginning, what we call the basement rocks or the foundation rocks of the earth, under all the continents and the crust of the earth. And then the pre-flood period probably saw some sedimentation as rivers carried sediments into the oceans in the pre-flood world. And maybe there were some localized floods, but not a lot of the geological record would be in that period. And then we have the flood, very short period, but a lot of rock deposited, a lot of sediments deposited during that flood year. And then in the post-flood era, we would have some residual catastrophic effects from the flood, producing some localized sediments. We can look at that a little bit more detailed here when we see that the creation was actually, during that creation week, there were different stages. There was the foundational stage, but then on the third day you had the gathering together of the waters and the formation of dry land, which would have produced sedimentation and erosion during that period. And then the flood was a very complex event. You had the rising flood waters first erupting as the fountains of the great deep and the waters erupted, then the water reaching its highest level, and then the waters beginning to abate, and then finally as the soil dried out, you have all of those stages. And then you have in the post-flood world probably a couple of centuries of residual catastrophic localized geological activity, and then eventually the earth kind of recovered from this massive convulsion to the processes we see today in modern times. Now let's look at some more evidence for that global flood and a young earth. There are actually lots of different ways that we can look at the age of the earth by physical processes. Take, for example, the amount of salt in the ocean. We know that there are many ways in which salt goes into the ocean, through erosion, through water coming, hot, briny water coming up in the bottom of the ocean. And there's certain ways that salt can get out of the ocean, through evaporation and salt spray, ocean spray, and that kind of thing. And scientists have been able to calculate pretty accurately on a global scale how much salt is going into the oceans and how much is leaving the oceans. And what we find is that the oceans are getting saltier and saltier every year. More is going in than is leaving. Now, if we assume, as a uniformitarian might assume, no salt in the beginning, and if we make the uniformitarian assumption of the same rate of addition of salt to the ocean as we observe today, all the way through past history, which is an assumption, it's not an observation, we get a maximum age for the ocean of 62 million years. Now, that's not the real age of the ocean, because the flood would have brought a lot of sediment and salts into the ocean. So the actual age of the oceans is much, much younger than that. But even with the uniformitarian assumptions that the evolutionists use, the oceans, the salt says the oceans are far, far younger than the evolution theory requires. Or we could look at the rate at which the continents are eroding into the ocean. And if we measure how much sediments are being taken into the ocean by rivers as the continents are eroded, we get a maximum age for the erosion of the continents of 14 million years. In 14 million years, there wouldn't be any continents left. And all the sediments on the bottom of the ocean would be formed. Another physical process is related to helium and the age of the atmosphere. When there are radioisotopes that decay, radioisotopes in the rocks of the earth that decay, they produce helium. And that helium is very light, very small. It wiggles its way through the lattice structure of the rocks and eventually gets into the atmosphere. We know how much helium is going into the atmosphere today, and we know that a little bit of it escapes to outer space, but most of it doesn't. So if we made the uniformitarian assumption of no helium in the atmosphere to begin with, and the present rate of helium going into the atmosphere now, we could get a maximum age for the atmosphere of just 2 million years, which is far, far less than the evolutionists require. So they have to come up with ways to say how this helium disappeared and why it was not going in at the same rate in the past. but that's an assumption. There's an interesting statement from a cave specialist. From 1924 to 1998, there was a visitor sign above the entrance to Carlsbad Caverns that said that Carlsbad was at least 260 million years old. In 1998, the sign was changed to read 7 to 10 million years old. Then for a little while, the sign read that it was 2 million years old. Now the sign is gone. Now what's going on here? I can guarantee you that from 1924 to 1988, the cavern was not getting younger. It was getting older by about 60 years. What's going on? What's going on is that the assumptions used to date the stalactites and the stalagmites and the other features, as the scientists studied those caves over the decades, they began to see our assumptions are wrong. These things formed faster than we thought they did. And now they're not sure how fast they formed, so they're not even guessing what the age is. The evidence didn't change. What changed was the assumption about that they used to interpret the evidence. There's another evidence that the Earth is not as old as the evolutionists say. They're what are called living fossils. And there are increasing numbers of creatures that are getting classified as living fossils. A living fossil is a creature that the evolutionists thought for many, many years had become extinct millions of years ago, and then we find a living specimen alive today, and it's identical to the fossil form. The Wollemi pine was a plant that was thought to have been extinct for millions of years, 150 million years, and in 1994 they found it in Australia, west of Sydney, growing just fine and identical to the fossil form. But that raises serious questions about those hundreds of millions of years. How could the plant survive over 150 million years and not change at all, if evolution over millions of years is true? Or the coelacanth. This fish was found in the fossil record in rocks at the same level as the last dinosaurs, and so the evolutionists thought this fish had become extinct 65 million years ago with the dinosaurs. And they looked at these fossil fins and said, well, those look really powerful. We imagine that they were used for crawling on the bottom of the ocean, and this fish was probably a precursor to amphibians that would actually walk out of the ocean onto the land. Well, that's what they thought until 1938, when they found a coelacanth swimming off the coast of Madagascar, identical to the fossil form, and they studied it in the wild with cameras and found these fins are never used for crawling on the bottom of the ocean. They're used for swimming in heavy currents, maintaining their positions while they're feeding. This is not something on the way to becoming an amphibian. This is 100% fish. They've since found it in fish markets in Indonesia and Japan. Looks identical to the fossil form. How could this fish live for 65 million years and not change at all, if the 65 million years is really true? Or consider this. Algae, the oldest living fossil, dated at 3.5 billion years, and it's identical to blue-green algae living today. How could these creatures stay the same for 3.5 billion years? It's very unlikely. What it indicates is these things aren't 3.5 billion years old. They're just a few thousand years old. Well, how long does it take to make fossils? Here's an interesting statement from two evolutionists in a book on dinosaurs. Fossilization is a process that can take anything from a few hours to millions of years. Now stop again and think. How do they know it takes millions of years to make fossils? The answer is, they don't. That's an assumption. That's not an observation. How do they know that it takes a few hours? That's observational empirical science. Watch. The amount of time that it takes for a bone to become completely permineralized is highly variable. If the groundwater is heavily laden with minerals in solution, the process can happen rapidly. Modern bones that fall into mineral springs can become permineralized within a matter of weeks. Now notice, it says groundwater heavily laden with minerals in solution. Now what would you have if you had the flood? That's precisely what you would have. Water filled with minerals in solution. And the flood didn't happen weeks ago, it happened 4,500 years ago. We got plenty of time to produce the fossils that we see. And we see in the fossil record lots of evidence that fossilization must happen rapidly or there won't be any fossils. Here's an ichthyosaur caught in the act of giving birth. This creature was swimming along, it was engulfed in a sediment-choked wave and buried alive. And before micro-decay organisms and oxygen in the water could destroy all of the evidence, it was fossilized. Or look at this fish caught in the act of eating its lunch. Now, fish decay very rapidly. There's no way that that fish could lay there on the sediments on the shore of a lake for weeks or months or years. And we notice not only that the bones are preserved, but many times in the fossil record we see even the soft parts of the fins. That means rapid burial, rapid sedimentation. And then we see around the world not only scattered bones, but we see creatures like this dinosaur almost completely articulated. In other words, their bones are all in the right relationship to each other. But how can you fossilize a dinosaur? You can't bury that thing a millimeter a year. The evidence will be gone by the time the sediments gradually pile up. This speaks of rapid fossilization, rapid burial. What about jellyfish? Well, they don't have any hard parts. How can you fossilize those? Well, you have to do it rapidly. They found that often in storms, jellyfish will be washed up onto the shore. And they do something in this position. They start pumping, hoping that another wave will come and they'll be ready to get back into the water. But if they don't, they die. And they very rapidly disintegrate and disappear. But a few years ago in Wisconsin, they found layers of rock that they date at 500 million years. And they found 7 different layers where they find impressions of stranded jellyfish that look just like jellyfish stranded today. And the ripple marks, again, as we looked at last time, indicate rapid burial. Well, let's finish up our session today with a rather extended look at radiometric dating methods. And we need to understand how important these are for the Christian view of the scriptures. Here is Steven Weinberg, a very famous, world-famous astrophysicist, and he says, the understanding of radioactivity allowed physicists to explain how the sun and Earth's cores could still be hot after millions of years. In this way, it removed the last scientific objection to what many geologists and paleontologists thought was the great age of the Earth and the sun. After this, Christians and Jews either had to give up belief in the literal truth of the Bible or resign themselves to intellectual irrelevance. Well, radioactive decay was discovered about 100 years ago, and shortly after that, they developed a method of using these radioactive isotopes to date things. This is how it works. You have radioisotope like uranium-238, which is an unstable isotope, and it decays unstable isotopes until it finally becomes non-radioactive lead. And in this process, it gives off alpha particles, radiates energy, and so this is the process. Now, uranium is called the parent isotope, and lead is called the daughter isotope, and the length of time that it takes for half of the parent to change into the daughter is called the half-life, and for uranium, that has been estimated at 4.5 billion years. Now, that's not an observation. They've only been observing this decay process for 100 years. So what's going on again? Uniformitarian extrapolations over long periods of time. There are a number of radioisotopes. There's potassium argon with a half-life of 1.3 billion years. Uranium we looked at. Rubidium strontium with a half-life of 49 billion years. And then the most famous one that most people know about, carbon-14, which decays into nitrogen in about 5,500 years. Now, first thing we should know about these dating methods is that in general, dates in the correct ballpark are assumed to be correct and are published, but those in disagreement with other data are seldom published, nor are the discrepancies fully explained. So that means, now, you're let in on a secret. When you read in the Cincinnati Enquirer about some fossil and they dated it at 240 million years old, you now know, oh, that's not the only date they got from these methods. That's the one they thought was the right date, and that's the one they published. That's not all the dates they got. In fact, there's lots of examples of where they have gotten many, many different dates. One famous example is skull 1470 found near Lake Rudolph in Kenya back in 1972. And it was a cover story article in National Geographic. The people that found this claimed that this was one of the oldest humans that had ever existed, and they dated it initially at 2.6 million years. But this was unacceptable to the evolutionary establishment because this skull was too human-like. And they said, no, there weren't any human beings back 2.6 million years ago, so we got to redate that thing. Well, it's an interesting story about this dating. Originally dated at 2.6 million years by dating some volcanic deposits near the fossil. They used, however, 4 different methods to date the rock, and the range of dates was from 500,000 to 17.5 million years. So, how did they get that one? Well, over the next 10 years, they had quite a debate in the scientific literature about this, and finally they settled on 1.9 million years. And how did they figure that was the correct date? Because it was based on nearby pig fossils. Well, how did they know how old the pig fossils were? The assumption of evolution. They assumed that the pigs existed at a certain time period, and so they used that to then pick the radiometric date that they wanted. And the whole story of this is in a 20-page appendix on human evolution by a creationist, Marvin Lubinow, Bones of Contention. Fascinating study of how these dating methods were manipulated to get the dates the evolutionists wanted. Back in May 1980, beautiful Mount St. Helens rose above the landscape in eastern Washington. But on May 18th, there were no sailboats on Spirit Lake at the base of the mountain, because the scientists, the geologists, knew this mountain was an active volcano when it was about ready to blow its top. And at about 8:30 in the morning on May 18th, it did blow its top. It knocked off about a third of the volcano, and in the crater here, after the eruption, lava continued to ooze into the crater, producing a lava dome. This is a view looking down from the mountain. You've got Spirit Lake here, and covered with a lot of trees. And here's that lava dome. Now, Dr. Steve Austin got permission from the National Park Service and his wife to climb up on Mount St. Helens and take some rock samples. He was trained at Penn State University by leading evolutionists in how to do this. So he got his samples. He went back to the lab, prepared them, sent them off to one of the leading labs in the country that does radiometric dating, and said, would you please date these rocks for me? And the results came back from 4 different methods. These rocks are anywhere from 340,000 to 2.8 million years. But what are these dating methods telling us? They are telling us when the rock crystallized into solid rock, when the lava crystallized. Well, we know when that happened. It happened after the volcano blew its top. So the rocks are actually less than 25 years old. Well, evolutionists will sometimes say, well, we'll concede to you creationists that these radiometric dating methods aren't absolutely perfect, but they're not off by millions of years. Oh, yes, they are. And there are many examples in the published literature of rocks of known age where we know when the volcano erupted, and when we date the rocks, they give us the wrong dates. This is Mount St. Helens. Here we have a lava flow in Hawaii where there's eyewitnesses that it was sometime in the last 200 years. We're not exactly sure, but the dates they got were anywhere from 0 to 22 million years for the rocks. The dates should all come back 0 because radiometric methods can't measure 200 years. That's too tiny. And then another one in Hawaii. The eruption was in 1800. And look at the range of dates, even up into the billions of years. There's something wrong with these methods. Here's another example. In Grand Canyon, you have 2 major lava flows in Grand Canyon. You have the Cardenas basalts down here at the bottom, and then you have these lava flows that poured over the side of the canyon. Now, clearly, from the physical evidence, these rocks are older than these rocks, because these rocks were formed. Then there was an erosional event which leveled that off. Then all of these sediments were deposited. Then something happened to erode this huge canyon, and then the volcanoes erupted and spilled their lava over the edge. All right? That's clear. Now, the evolutionists say that this pile right here represents 300 million years of time. So if we apply the radiometric dating methods and they really work, these rocks should be at least 300 million years older than these rocks, right? These had to form after those. You don't put the syrup on the pancakes before you put the pancakes on the plate. You put the pancakes down first, and then you put the syrup on. All right? But Dr. Steve Austin took samples, sent them off to the radiometric dating labs, and the results were from 13 different dates that they applied different methods. Here's the range of dates, huge spread of range of years. With rubidium-strontium isochron method, they got a date of 1,000 million years, 1.7 billion years. So these rocks should be at least 300 million years less than that. So at least 770 million years, maybe less than that. When the dates came back, they were over almost 300 million years older than the ones down here. It's impossible. They have to be younger. And then just recently, Dr. Andrew Snelling, a PhD geologist, did samples, 27 samples of these igneous rocks down here in the bottom part of the Grand Canyon. And they found, even with closely spaced samples that were only 0.8 of a meter apart, a little more than 2 feet apart, in the same lava flow, they got ages ranging from 1,200 million years to 2,500 million years. Something wrong with these dates. So, when we have rocks of known age, whether we have the absolute age when they actually erupted, or the relative age that we can see, well, by the physical evidence, these rocks here have to be older than these rocks up here. When we apply the dating methods, they don't work. But the evolutionists want us to believe that when we're dating rocks of unknown age, where we didn't have any eyewitnesses there to observe when the volcano erupted, they want us to assume that they do work. That's not logical. If they don't work when we can verify them, why should we trust them when we can't verify them? Here's some really exciting evidence that just occurred in the past year. And it relates to carbon-14 dating, which we haven't talked about. Now, there are several places in the geological record. This is how the evolutionists imagine the rocks of the Earth as we go down through the Earth. You need to know that this doesn't actually exist anywhere except in textbooks. You can't drill down into the Earth and find this nice progression of fossils. There is a general order, but it's not nearly as neat and tidy as this. But there are several places in this geological formation where we find massive coal deposits. And one is in the Eocene, which is dated at 36 to 57 million years. One is in the Cretaceous, which is dated at 66 to 144 million years ago. And one is in the Pennsylvanian, dated 286 to 320 million years ago. Now, carbon-14 is dating when the plant or animal died. That's what it's telling us. Now, evolutionists have never tried to date coal. Coal is made from plant material. And the reason they've never tried to date it is because it's millions of years old. There would be no carbon-14 left in the coal. So it's a waste of money to even do the research. There wouldn't be any there. It'd be a matter of tens of thousands of years and all the carbon-14 would be gone. So they've never tried. Well, creationists believe that there may well be some there. And so they got samples from these 3 coal samples. Look at their different ages, but when they did the radiometric dating with carbon-14, they found that all of the samples are essentially the same age and only about 70,000 years, the amount of carbon-14. That's a maximum date. There's something seriously wrong here. And what's wrong is the assumptions that are being used in the method. They're assuming a constant decay rate. And there's strong evidence that that decay rate is not good. Now, let's look at one last example. Diamond is the hardest substance known to man, and scientists believe it's formed deep in the earth under high temperatures and pressures. And they believe it's anywhere from 570 to 4,500 million years, 4.5 billion. Well, Dr. John Baumgartner decided, well, the carbon-14 applied to coal gave us some unexpected results. I wonder what would happen if we tried to use carbon-14 on diamond. There should be, if those diamonds are really millions and millions of years old, there should be no carbon-14 in the diamond. Well, he's taken 5 samples and dated them with carbon-14, and they come out to dates of less than 58,000 years. Incredible. This has just been published in the last year. Incredible research. So what's the problem with all these dating methods? The problem is the assumptions in the methods. The problem is not our technology. We've got mass spectrometers that can count the individual uranium and lead atoms or carbon and nitrogen atoms. The technology is superb. The problem is in the assumptions. You got the daughter and the parent isotope. There are 3 main assumptions in this method. First, what was the original ratio? If when the rock formed, when it crystallized, it had only uranium, so 100% uranium and no lead, we'd get a very different date than if when the rock formed, it was 51% uranium and 49% lead. If we assume 100%, 0%, we're going to get a much greater age than the actual age. Another assumption is the rate of decay, and I've already indicated. The evolutionists assume that in this illustration, the sand has always been falling down at the same rate. The radioactive isotopes have always been decaying at the same rate that we observe today. But we've only been observing them for a fraction of the supposed time that they've been decaying. And the creation scientists have believed for several years that there's strong evidence that those decay rates have not been constant. And just in this last year or two, they've uncovered some very powerful evidence that they were much, much faster in the past, at the time of the flood, and maybe at the time of creation. And that would accelerate all of those decay processes, which would bring those years from millions and billions down to thousands. And then the last assumption is, has any of the parent or daughter isotope moved in or out of the rock after it crystallized? If you've got leaks in the system and you don't know that, you're going to get erroneous dates for when the system was formed. So we are constantly bombarded in the news and in our textbooks and movies that the fossil and geological record represents millions and millions of years. But it doesn't really. What it represents is the record of Noah's flood, and that this is a young earth after all. And the reason that people don't see the evidence is, as a very famous British historian of science said about the 19th century, then as now, men often perceive what they expect and overlook what they do. And see, people don't want to see evidence of a global flood, because what does a global flood speak of? It speaks of the wrath of God. And people who do not want to submit to the holy demands of their Creator are going to think of every way possible to explain away the evidence, so that they do not have to be morally accountable to their Creator. So, what we are trying to help people understand is that if you start with biblical assumptions and you go and look at the facts, whether they're the facts from outer space or the earth or living or fossilized creatures, if you start with those biblical assumptions, you will come to a correct interpretation and understanding of reality. So the earth really is confirming what the Bible says.
Questions on that? What do you guys think?
Well, I like the way he explained that, because that's always been something that I'm trying to figure out, is how do they, what does this data mean? So it's the degradation of one element into another, and that,
Yeah,
that's
which they can measure, right, as he said, right? It's the initial assumption. and again, depending upon who you talk to, there are scientists out there that say, hey, we know the K rate's been constant, and it's never changed. There's other scientists out there that say, and there's papers written that know the K rate can change, and there's one I found, that the sun actually has an impact on, like the Earth distance to the sun, they've measured has an impact on the decay rate for whatever reason, I don't know. But there's other people who say, no, that's not the case, and here's my data. So again, it's depending upon whose camp you're in, depends upon what you think about the assumptions going into these.
You make this assumption that, to Mark's point, education is so important, and knowledge and insight and all that, but there's, the education system at least seems so intellectually dishonest, because it doesn't admit all of the things they don't know as they're teaching their kids, and so, it's disappointing that there's alternative options, and those aren't shared, or as part of the pursuit of knowledge and insight, this information can be shared, and I get, okay, they're young, and the kids, maybe, I'm not an expert in education for sure, but it's disappointing that there isn't at least some alternative provided, because our kids did not get any alternative provided.
Right.
It was black and white.
And they might learn something at 5th grade that then can be expanded. You know, you learn a little bit about the cell at 5th grade, then you learn more in the high school range and things like that. But I agree, I've never seen this transition into, why are there different views of this?
Yeah, or
You
different.
know, hey, we shared with you a simplistic view earlier, now let's talk about the more complex. We do with a bunch of other things, but we don't do it with this, you know, so it's interesting, yeah.
There's a good reason for that. They teach the predominant scientific views because if, like 99% of people believe this is correct, then that's what they teach. It's not like journalism where every voice gets equal time. It's like, we're pretty sure this is what happened. There's obviously some level of doubt.
Yep.
But some of this is pretty fringe stuff.
I don't deny that at all. Yep. The 99% of
It doesn't shock me
scientists.
that this doesn't show up in school curriculum.
But what I would say, the one thing I would agree with that is, if it's presented as the way it is, but there's never the doubt presented. It's never presented as, this is the way we hypothesize it, but this isn't totally proven out. It's always the first part. And so young kids say, well, they say it's true, there's nothing to really doubt about it. There are things to doubt about it. Doesn't mean it's not true. But if you're not presenting that there are potential doubts, you're not creating an opportunity for people to critically think.
Yeah, I would say shame on the system if they're not teaching people to question the data, because that's what science is all about.
Yeah, right.
That's how we learn more stuff, is like, oh wait, this doesn't totally explain this correctly, let's modify this.
Yeah, but Mark's right, the scientific community would say, well, this is very fringe. And the majority of the scientific community would say that. And actually, something that we're gonna talk about, I think next week next week, no class. I'm gone, but then the next time we have class, and actually Scott showed me an article during the week, there's a growing community of PhD scientists from very, I don't know what you call it, esteemed, prestigious universities. And it's called Descent from Darwin. It's actually a website. I think it's descentfromdarwin.com, I believe. And right now, I listened to a podcast on it. There was, 15 years ago, there were maybe 100 scientists who had signed it. 10 years later, there were 400 scientists who had signed it, and now the number's up to over 1,000 scientists have signed on to this. Now, that doesn't mean they believe in a young Earth. That just means that there's a growing number of people in the scientific community who are starting to question the tenets of Darwinism and evolution, and that the way it's portrayed as having happened based on the increasing data that we have doesn't seem plausible. And we're going to talk more about that data in the next couple of weeks coming up here, as to what they're finding. And again, it's at the cellular level, within DNA, information theory. Where does all the information in our DNA come from? That type of stuff. It's very fascinating. Any other questions? All right, why don't we us in with a word of prayer. Dear Heavenly Father, you say this every week, but thank you for the opportunity to be here and just to be able to discuss your word and to agree and disagree, to have civil conversation about it. Help us to use this to strengthen our own faith in you, because that's the ultimate goal, Lord, is our faith in you. We pray this in your name. Amen.
Thanks, Jeff.
Thank you.
Yeah, thanks.
All right, Mark, what homework you giving me this week?
Yeah,
You get the week off, you get the week off, because we're not meeting next week.
Well, you got to give it to me now in case I don't see you.